Okay, today we're going to dive into something pretty incredible. How you can take a simple PDF, a document about the Falklands War, and use AI to turn it into a dynamic, interactive battlefield simulation. Let's see how it's done.
It sounds like a trick question, right? How can you predict something that's already happened? Well, in a way, you can. It's really about testing our understanding of the past by turning a historical account into a living model that we can actually run and experiment with.
And that, right there, is the biggest problem with any historical text. It gives us the story, the timeline, the final score. But it can't easily show us how one tiny change, a different strategic decision, a bit of bad weather, might have completely changed the outcome. Until now.
So how do we actually bridge that gap between a flat document and a dynamic world? We're going to dig into something called a reproducibility simulator. In this case, it takes a Wikipedia article on the Falklands War and basically brings that whole 74-day conflict roaring back to life so we can start asking those juicy what-if questions.
So, what is this thing, really? Think of it like a super smart reader. It scans the text, pulls out all the key facts and figures, the hard numbers, and then builds a mathematical model of the conflict. It's no longer just a story we read, it's a system we can test, one that creates its own data based on the rules it learned from that original document.
So how does this what-if machine actually get built? Well, it all starts with the AI reading the source material almost like a historian and pulling out all the critical data points that are going to be the engine for our simulation.
And what I think is really cool here is how transparent the whole process is. The system found 25 key numbers or parameters stated directly in the text. But for 10 others where the info is missing, like, say, daily equipment failure rates, it made educated guesses. And the best part? It tells you exactly what it found versus what it had to assume.
Let's see this in action. The first big number the AI grabs is the total size of the British Naval Task Force, 127 ships. That becomes a cornerstone of the entire model.
And here, this is awesome. You can see exactly where that number came from. It's right there in the text. The AI reads about the 43 Royal Navy warships, adds in the support vessels and merchant ships, and turns all that text into one simple, powerful variable.
Okay, so what about the other side? The simulator looks for Argentina's starting strength, and it finds this: 122 combat-ready jets at the start of the war.
And yep, here's the proof again. The AI finds this exact figure in the document, and that becomes another crucial starting point for the simulation. It's literally pulling the words off the page and turning them into code.
All right, one last big piece of the puzzle, the time frame. How long did this all last? The AI extracts the historical length of the entire conflict, 74 days.
And this number basically becomes the master clock for the whole simulation. Every single event, every battle, every calculation is going to happen inside this 74-day window, just like it did in real life.
So, we've got the raw numbers. Now for the really cool part. How does the simulator actually use them? Let's pull back the curtain and see how the model itself is put together.
The simulation is built on something called an agent-based framework. Now that sounds complicated, but the idea is simple. Instead of looking at the war from 30,000 feet, it models every individual unit, or agent. So every ship, every squadron of planes, every group of soldiers is its own little piece in the game, making its own decisions day by day.
And because of that, the model can track all these moving parts. It's keeping a running tally of everything. How many UK ships are left after a battle? What's the fighting spirit or morale of the Argentine forces looking like? How much of the islands do the Brits actually control? This isn't just static data. This is the war coming to life, day by day.
And this is where it gets really, really fun. Once you have a model that perfectly recreates history, you can start tweaking the numbers. You can start exploring all those alternate timelines. This is where we run the what-if scenarios.
So the team ran 5 key scenarios. First, they ran the historical baseline, just to make sure the model was accurate. Then, they started playing God, asking things like, what if Argentina had total air dominance? Or what if the UK sent a smaller force? Let's see what the simulation predicted.
First things first, let's ground ourselves in reality. This blue line shows what the model says happened in the actual war. See how territorial control bumps along at 0 until the British land around day 49? Then it climbs steadily to a UK victory on day 74, and boom, it nails it. The model perfectly recreates what actually happened.
Okay, now for our first what if. What if Argentina had more jets and better missiles from the get-go? That's the red line.
And, get this, the outcome is pretty much the same. The simulation suggests that even with a big advantage in the air, the final result on the ground might not have changed. Now that is a fascinating insight.
But what if the UK had sent a smaller fleet? That's the purple line right here. And this is where the model reveals something huge. The path to victory becomes so much slower, so much harder. The simulation shows just how absolutely critical the size of that initial British force was to the real-world outcome.
And remember, the simulation isn't just tracking ships and land, it's also tracking intangible things like morale. Here we're looking at the Argentine Morale Index. See that steady decline? And then notice that sudden, sharp drop right around day 31? That lines up perfectly with the sinking of the cruiser General Belgrano, a devastating historical event whose impact we can now actually see quantified.
So you see, this is way more than just a cool TAC demo. Being able to truly simulate the past gives us a completely new lens for understanding why things happened the way they did. Let's talk about why this is such a big deal.
I mean, think about who can use this. For military historians and defense analysts, this is a game changer, a new way to test old theories and wargame future conflicts. But just as important, for teachers and students, it turns history from something you just read about into an interactive laboratory where you can actually experiment with cause and effect.
And this kind of technology is really just getting started. It helps us move from simply reading about what happened to building a real, quantitative understanding of why it happened. And that leaves us with a really exciting question, doesn't it? If we can bring any documented event to life like this, what part of history should we simulate next?